All right, class, let's keep going. It says here, if f of x equals this function right here, what is the value of f of 6? So basically it's asking you to take 6 and plug it in here. The easiest way to do this in Desmos is plug in the function. So f of x equals x minus 3 squared plus 1. And then it's asking you what is f of 6. So we're just going to put f of 6 right here. And it's 10. What it did was it took the 6, it plugged it in here, and then it calculated. So basically it did, you don't have to do this part, but I'm just showing you what Desmos did for you. Okay? Anyway, what I want you to do on the SOL is plug in your function, plug in f of 6, and then there's your answer. Next question. Which number is not an element in the domain of this relation? So the domain is -2, 0, 1, and 6. 1 is in the domain right there. 0 is also in the domain. 4 is not in the domain. That's what it's asking you. Okay? And -2 is in the domain. That's about it for that one. All right, using the equation of the line of best fit, which number is the best prediction of the output when the input is 13? Okay, output, input, what does that mean? Well, output is y, where your input is x. So I'm going to go ahead and, whoops, I didn't mean to click that. I'm going to go ahead and plug in all these points in the table form. So -5, 2, 9, 11, 0, and 5. And then over here, 9, 31, 143. Okay. 151. 42 and 97. I'm just trying to look to see what kind of pattern. Well, actually it tells you right here. It's a line of best fit. So this is something you have to kind of memorize and study. I gave you guys the notes for this, note sheet for this. So it's y1 regressed against a x1 plus b. This is for the line of best fit. Okay? Once you come here, you have your A and B, and it also, draws that line for you. So basically what you're trying to do is you're trying to find y, which is your output. What is the best prediction for y when your input is 13? So I'm going to put A, it copies it down for you, and then x is 13 plus b. It's at 170. That's about it. Yeah, I don't know what to say about this one. Yeah. All right, next one. I'm just gonna make this a little bigger so that the layout looks fine. Okay. A representation of a function is shown. So basically they give you a formula for a function, an equation. What are the x-intercept and the y-intercept of this function? Okay, so that's easy. We can just graph it and find it. So I'm going to go ahead and plug in my function. And I'm going to press home. So it's right here. Be careful here because we want to make sure we're picking the right point for what it's asking for. So let's look at the x-intercept. The x-intercept is 0.5, which is about 1/2. And then the y-coordinate is 0, this one. And then the y-intercept is 0, 2. Okay, so remember x-intercept has 0 for y, and the y-intercept has 0 for x. But that's about it for that. A scientist dropped an object from a height of 200 feet. She recorded the height of the object at 5-second intervals. Her data is shown. So I see a table. I'm going to just start off by putting it in here. 2 and 2.5, 5-second intervals. When you're plugging in the table, just make sure that, you know, you don't, oh, see, I told you to make sure, but I'm not making sure that I did it right. So 1.5 is 165. Let's take a quick look, make sure that all of the numbers are matching. Yep. Okay, now let me read the rest of it. It says, based on the quadratic model, which best approximates the height at 3 seconds. So we're looking for 3 seconds here, but well, I need to go ahead and put my quadratic regression, which is y1. The earlier question, we did a linear, now we have to do quadratic. So y1, ax1 squared. Squared is what gives it that quadratic shape right here. And then let me zoom out so you can see the points. There's the data right there. But you have to type up the whole thing, plus bx1 plus c. This is also something you have to memorize. Okay, and then I have my a, b, and c. It says, based on the quadratic model, what best approximates the height at 3 seconds. Sorry, I didn't mean to click on that either. But so at 3 seconds, I'm going to find the height, which is y, equals a x squared plus b x plus c. Okay, that's my quadratic right there. So what I'm going to do is I'm going to go ahead and plug in 3 here and here, because it's the same. 67. All right, I think I did something wrong. Hold on. So 0.02, 0.5, 1. Wow, see, there's this number that's off here. 185. That changes my answer to 55. So making sure the table is done right in Desmos is super important. Right? And that's what I have here. Just if you need to see this again, just go back in this video and just watch the steps again. Okay? What is the range? So you know that the range is the y coordinates. So all you're going to do is measure each point on the y-axis. So the y coordinate here is -4. Here the y coordinate is at 0. Here the y coordinate is 2 and 4. So -4, 0, 2, and 4. -4, 0, 2, and 4. That's about it. Okay, this question. The graph of the function g of x is shown. What is the approximate value of g of 3? So basically, this is your input right here. Okay, so it's asking you, what is your y value when x is 3? So I go to x is 3, and my y value is at 1. And that's about it. Yeah. Which table does y vary directly? So remember that the direct variation, it goes straight through the center right here to the origin. All right, I'm just going to plug the tables in and see which one looks like it's going through the origin. Well, that's definitely not, because it has to be tilted here. So that's not it. Let me try B. I think that's it. So like this is up to the left, down 4, to the left 1, down 4, to the left 1 and down 1, 2, 3, 4. Yep, it's headed right through the middle. That one. B. Find the values of the range when the domain is this. Okay, so basically find the y values, which is the range, when the x values are this. Okay, so I'm gonna do this as a table. I'm gonna take this and I'm gonna convert it into a table. Okay, I'm going to take that, I'm going to convert that into a table, and then it says my domain is -2, change that to 3 and 8. I'm going to take these off so I don't confuse myself. So the range is 9 and negative 3.5. The 9 is repeating, so I don't have to pick that twice. You just have to write it twice, and then the negative 3.5. And that's about it for that one. It says determine whether the following table represents a direct which of the determine whether the following tables represents a direct variation. The question is written weird, but basically I'm looking for which table has a direct variation. So I'm just going to graph them. The easiest way to do it is to see which has a trend going through the origin. Well, I don't think that's it. Let me check another one. Negative 4, negative 2 and 6, negative 8. I don't want this one. I think that's good, but I just want to make sure that I check the other one too. I can unclick those ones instead of erasing it actually. Negative 3, 6, and 8. And then right here, negative 12, 24, and 32. All right, I don't know. They both look the same. Let's go ahead and calculate the slope. So, down, it's left 1, 2, 3, 4. Left 1, 2, 3, 4. Left 1, 2, 3, 4. Left 1, and then 1, 2, 3, 4. Okay, well that's going through the center. And left 1, 2, 3, 4, and then this one didn't match. So I don't think it's this one. I believe it is going to be this one right here. Let's check. So that's up 1, 2, 3, 4 over 2, 2, 3, 4 over 2. Well, that goes, we just have to make sure if it goes up there. 1, 2, 3, 4 over 2. I think that's good. Okay, well, I'm going to show you maybe another way to do this problem. So if you want, a direct variation is when your x and y values are, when you multiply them, or sorry, you divide y over x, you get the same number. See, that one's off a little bit. Same thing here. If I did take this off, x and y, and then do y over x, see? Yep, it's the green one. It's this one. There you go. That's the last question, guys. Yeah, I'll stop the video here. Thanks for watching.